I'm going to, I have to see if I'm recording. I'm going to try a transformation of this function, which I have to know the parent function. The parent function of this is y equals x cubed. And on a cubic function, I can look at the inflection point. It's right there. This inflection point is shifted 1 to the right and 2 up. So the right shift is opposite sign, right is negative, so x minus 1 cubed, and then 2 up plus 2. Now, I can get the second part. I can find out there's a vertical stretch or compression or horizontal stretch or compression. I can express it either way by looking at some points. And I see a real clear integer points. Negative 1, 1 is right there. I could also use 3, 3. But I think negative 1, 1 is going to be easier to use, so that's what I will use. Negative 1, 1. And if I want this to be if I want to express it as a vertical stretch or compression, the A goes outside. If I want to express it as a horizontal stretch or compression, I'll use a different letter. I'll use B times x minus 1, and that's inside. Hold on, I don't like the way that negative sign connected to the 1. Inside the cubing, because it's a horizontal stretch or compression. So I can express it either way, and I'll work it out both ways. And this is always y equals. I just use a different letter there. You could write A if you want to. But okay, let me work it out so I can express it as a vertical stretch or compression. I'm going to use this point, negative 1, 1. Negative 1 is x, 1 is y. 1 equals A times negative 1 minus 1 cubed plus 2. Negative 1 minus 1 is negative 2. Negative 2 cubed is negative 8. So 1 equals negative 8a plus 2. I will subtract 2 from both sides. 1 minus 2 is minus 1 equals negative 8a. Divide both sides by negative 8. Negative 1 over negative 8. That's just 1/8. And that's a. So this function expressed with a vertical, this is a compression, vertical compression. With the vertical, if it's less than 1, it's a compression. If it's more than 1, it's a stretch. Horizontal is opposite that. If it's more than 1, it's a horizontal compression. Less than 1, it's a stretch. So this is going to be written as 1/8 times x minus 1 cubed plus 2. So that is a correct answer. This equation equals y, of course. This equation will get this graph. Now I can also express it as a horizontal. In this case, it's going to be a horizontal stretch. If it's a vertical compression, it's a horizontal stretch. I'll do it the same way. I'll plug in the point negative 1, 1. 1, that's the y value, equals b times x is negative 1 minus 1, all of this cubed, plus 2. And notice I don't distribute this b, because if I distributed this b, then I wouldn't see what the horizontal movement is, and I want to see the horizontal movement. So I don't distribute that b. Well, I guess I was trying to get rid of that other arrow, but I guess it was too early. All right, so plus 2. Negative 1 minus 1 is negative 2. So b cubed, 1 equals b cubed is just b cubed, times negative 2 cubed, which is negative 8. So that's negative 8b cubed plus 2. I will subtract 2 from both sides. Negative 1 equals negative 8b cubed. Divide both sides by negative 8. Negative 1 over negative 8 equals 1/8 equals b cubed. I can take the cube root of both sides. Cube root of b cubed is b equals, cube root of 1 is 1, cube root of 8 is 2, so b equals 1/2. So I can also write this, and let me give myself more room to do it. I can also write this as, I'm going to use this one, but I'm going to put in the value of b, y equals b, which is 1/2, times x minus 1 cubed plus 2. So this would also be a correct equation for the graph shown in that image. Hold on, I'm trying to get to the graph shown in that image. Here's the graph shown in that image. Either one of these equations is correct. The first one expresses it as a vertical compression, 1/8 times x minus 1 cubed plus 2 equals y. The other one version expresses it as a horizontal stretch, y equals 1/2 times x minus 1, that whole quantity cubed, plus 2. Either one of those is correct.